Hello folks, well it's the 6th of November, so we had bonfire night yesterday, and as I drove into town with Mr. Chippy we did see one or two fireworks. Now, we've got here one which is another one which of my sets which is destined for eBay. It's got a bit of a fold there in its escutcheon. Can we unfold that? It's amazing what you don't see. I would think that a piece of RG58 is about the diameter. Oh well, it's less folded now. Right. Yes, these that's loose. It's probably failed foam rubber. These escutcheons, otherwise known as decals using the American word, are available as replacements, both from what's he called? He's got a thing on eBay, vintage electronics repair or something, and the bloke's name's Andrew, and also the other firm who do the plastic ones. But there we go. So they are readily available, but this is in nice condition. I'd rather have the fold than the original front. So there we go. And also, when you change them, as I've shown before, you've got to take the microphone socket totally off because it's bolted from the back, and then it's got to be unwired. There's a lot of extra work. So it's lost its power connector. We're going to put a new one on because we do supply the original type. The ones we get are black, aren't black, they're white, but that's the only difference. They are the real thing. They're not some pattern part. We'll just bear this for now, and I'll go through the servicing, and then I'll put a new power connector on at the end, and when we flog it, it'll go out with a new power lead. So I'm going to open it up because it's an unknown set of mine. I'd hate to power it up and damage it because there's something scary going on. You notice flogging one or two sets on eBay, and some of them are donations which have been donated to raise funds for our repeater. But sometimes we're running at a loss, aren't we, because they're so expensive to repair. Right, so what we got? Well, that ballast resistor arrangement isn't acceptable. They've done two in parallel, which is going to be what, 3.3 divided by 2, like 1.7 ohms. I'm not so bothered about that, but it's just not the right approach. So there we go. I'm not happy with that. So we'll put a new ballast resistor in, but I'm going to power it up and we'll try it as it is. There's a danger it could be overpower, and we don't want to thrash the PA, which is very, very expensive to get that transistor these days. We're not talking about fake ones off AliExpress that do 80 milliwatts output because they're really audio transistors rebadged. We're talking about the real ones, which were discontinued in 2000 by Mitsubishi. So you can't have shiny ones for sale. They're all going to be tarnished, any which are real and are for sale. So we've got to look after those, because last time I bought any they were 16 quid. Why is the tape there? They've done... Oh, they put some stupid LED behind the meter. Yeah, right. Okay. Let's have the audio IC changed. We'll clean the board. Right, so it looks safe to switch on. So we'll get the crocodile clip leads to it. So I'm hoping it's going to be pretty well where it should be and just need these few little bits and pieces. .8 volts, power on, dreadful blue LEDs. Let's put it on channel 20, tone high, Right, so we need our standard that was supposed to say generic microphone. We're going to have to check every radio. Now these sets are 40 years old. We're going to have to check every single one for tightness of the aerial connector. It's not so matter when we've got it on the bench, but certainly when we've got it on the roof aerial. Mr. Chippy keeps radioing in from a mile away and saying I'm a bit 10-1, and what it is, the aerial connector, the leaves inside, the springy leaves, they get sprained after 40 years of use. So that's tightened that one up, and then I'm also going to run over it to some extent with the fiberglass brush. There we go. So that's just precautionary. Oh, we'll plug it into the test equipment. So I was using the generic mic 2 days ago. Where's it gone? Some of those keychain whistling things going anyway, beep 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 beep. Could do with one of those with the mic on it. Okay, well I just found it in my kitchen. Probably trying to cook some sausages. Right. Clipboard. So it's my set. Here goes. Transmit. We're on the low light range. It's just doing above the low amount. It's doing 3.1 watts. And we've got the SWR alarm. We've got the alarm coming up. The alarm that tells me that it's got lots of out of band interference. So as I said before, this test set only reads power which is within a certain band, so it doesn't, like most power meters, will read power all over the place. Like if you've got a meter that reads 1.8 to 140 megs, it's going to read across the whole spectrum. So it's going to add up all that interference, and you go, oh, this radio's doing 7 watts output, when all of that's interference. I've demonstrated all that before, but it is putting up the alert. So 3.1 watts, channel 40, 3 watts, channel 1, I could put 2.98 or something, but I will say 3 watts. Back to channel 20, I can't think why it's putting up an alert, and you know what, is that could be the wrong kind of resistor. Anyway, we'll come to that. Low power. It's last set with this chassis. We had to replace that switch. Never had to do that before. It's doing 210 milliwatts, and it's a fixed thing, so there's nothing we can do about that. That will change when I sort the transmitter out, and hopefully we get a bit more out of them, because I really want it to do more than 3.6. Mind you, if you bought a new set today, you'd be lucky to get 2.7 out of it. Right, current consumption is 1.33 amps. Deviation, for what it's worth on this test set, wallow. Oh, so you've not got an ear as my machine wanting the tune up. Testing 1 2 1 2 1 2. No transmitted audio. Has it got mic gain? It's got mic gain. That's at full. So here comes a test. Is it working on PA? probably why they flogged it. Right. So I've got no transmitted audio. Let's see where it is frequency wise. Put up, not even put the picture in picture on, so you've not seen any of this. But we'll put up the frequency counter. Back, if we go off PA and back to CB, that is. $27,79065. 27,79065. I'd like it over 100 to flog it. I don't want it under 100. There looks to be some leeway. Obviously it's supposed to be 79125. Once we start getting under 79075, it starts to become noticeable. And if we went under 79025, it becomes off frequency, as in as a legal thing. But anyway, where on earth is, there it is, my instrument extension speaker, which is there. Right, so we'll put this frequency into our signal generator so it's a fair test of the receiver. 27,79065. The test gear's been on about 15 minutes. This will rise. I dare say that in an hour's time that will read as 27,075 anyway. So, receive. We've got 100 microvolts on, the meter's showing S5. For it to read 100 microvolts, oh, it never does. We've actually got a duff meter, it's jammed. So if I press transmit, makes no attempt. I actually got 3 meters lurking here in case we've got a duff one, but don't think any of them will be one of these. No. Right, back to where we were. Very, very good receive. It's one of these exceptional ones again. It's already 0.22 microvolts. For 10 dB, it's 0.2 microvolts. For 20 dB, it's 0.71. Now, squelch can be iffy on these. But on the genuine Japanese versions, it's usually alright. Not always. That's coming in at 100 microvolts, which is exactly where I want it to be. And let's see where the minimum is. Let's show you the attenuator. So we're at 0.3, we're parked there. Switch the signal generator on. Straight in at 0.3. So that is absolutely perfect. I can't think I'm going to get any improvement unless the detector's out and make it worse on paper. So switches are fine. I may have to check for tightness. Slip the front panel to one side, as I mentioned with the thing, just to make sure these are tight, because there seems to be a bit of float in the squelch control, but it just may be the way it is. So don't know yet. Sockets are fine. Right. The only thing we can actually do without doing any actual work is the VCO. So we'll set it to channel 20. Meter on. We'll use the red wire for the earth because I can. There we go. Red to black, black to earth. Use that coil can as earth. Far side of capacitor 9. Okay, we'll use that coil can as earth. We'll put the other glasses on. So it should be 2 volts. It doesn't have to be stupidly accurate. I mean, 2.19 is absolutely fine. On transmit, it should be 2 volts. And you know what? I'm not going to adjust the transmit one. Just going to touch up the receive one. Well, I would if it would move. I'm not going to even attempt. It's too close. Because it's not one. I'm going to apply heat. The polythene cores. So, yeah. So in receive, needs to be around 4 volts. Somewhere between 3.2 to 4. And on transmit, the same applies. So, there we go. So had it moved easily, we'd have done it. But if I start having to get the hairdryer out and the earwax removal drops and all that kind of stuff, it adds another unnecessary layer. Right, so what I do need to do is to change this resistor. They're not even getting warm. I'm not sure what's happening here. Anyway, it's coming out. We'll put the right one in. Never put the soldering iron on. Okay, well, go and look for a resistor whilst the soldering iron warms up. Right, I'm back with you. What I did, I put the radio over a convector heater, a 250 watt convector heater, and all these coils have become really easy to move. I'm going to put it on frequency first, although we'll have to reset it again because the set's warm, too warm. Right, we'll plug in the test instruments into the aerial socket. Make sure picture-in-picture's on. Frequency counter is 2779070. So see whether we can bring that up. So it really needs to be more than 100. It really needs to be 125, but it probably isn't going to do that. It's very close, isn't it? 79110. In about 12 years it'll probably need the crystal changing, which will be longer than a new set is likely to last. Right, let's do the transmit. So centre of the peak. We're at 3.6. I've got to turn the soldering iron off. while we're waiting for the soldering iron, I'll do the deviation. Oh no, we can't, can we? It's broken. Testing 1, 2. It's not now. What's happened there then? How bonkers is that? Okay, what is it on this test set? Wow, it says 3 on this test set, so we'll do the deviation. We warmed up a dry joint. I'll get Mr. Chippy to check for that. Wow, it's 1, 2. It's 4.2, which is ridiculous. Wallow. Peaking at 2.5 now. Right, we're back onto the Marconi test set. See whether it's saying anything similar. Wallow. It's a bit reading a bit low today. We don't take any notice of it. 4.2. 2.2 to 2.5 kilohertz. Right, let's see if we can get a bit more than 3.6 watts. It's been doing 3.6 watts. It's been doing less than 3.6 kilowatt for 40 years. .6 and a bit watts. .8. I'll just make sure these coils are placed properly. Absolutely critical. .4 watts. Now it may be slightly over the top when it's warm. I'll start again. It may be slightly over the top when it's cold. I'm just checking this tightness of this transistor. I'll just have to turn it down a fraction. It's 4.1 when hot. So it will be slightly over the top when it's cold. So channel 40, 3.95 watts. Channel 1, 4.05. Right, low power. Let's hope it's better than 300 milliwatts, but it probably won't be. It's now 310 milliwatts. And our current consumption for... oh, that was channel 1. That was a flawed test. It is 310. And the current consumption on full power is now 1.30 amps. So look at that, our current consumption's come down. We've got 0.9 of a watt more because it's tuned properly. So that was well worth putting over the convector heater for an hour. Now, how many people have got a 250 watt convector heater? I mean, I bought it in specially years ago to do this kind of thing. It's a Belling one from the 1950s. Right, so mysteriously our audio's come back, and it's going to be a dry joint, so I'll get Mr. Chippy to look at it once we've cleaned. I'm going to have to do the meter lamp. Yeah, right. Why would you want it to... Why would you want a 40-year-old set, to... I'll tell you what, we're going to disconnect that before this causes some issue. Why would you want a 40-year-old set to have an LED when LEDs like that hadn't been invented 40 years ago? Still quite some time consuming work. I mean, when I've got this tuned, I bet there's another 90 minutes work to do. So it's actually beyond any value, isn't it? Testing 1, 2. Right, done with that. Receive. It was absolutely excellent on receive. You know, this whole set's been tuned very well. I mean, I've done the ballast resistor for a really high quality military grade one. It's the only thing that's changed. So detectors here. Let's go over to camera 3. It's about right. We're not going to get anything better out of the front end, I'm absolutely sure. Let's go over to the synode meter. I think it's got a broken core. Let's do these IF ones while we are at it. Okay, what I'm trying to do, I've had to unsolder this coil with it having a broken core. Maybe in the right position, but it isn't good. Why can't I get it out? I wonder if the coil, I wonder if the pin that isn't soldered is soldered. Do you get that? It could just have a blob of solder on the pin. It's seesawing on something. It all looks clear. Okay. So we've got this cracked core. How do we get it out? Well, let's hope we can remove it through the bottom. And turn it round. And put it in the other way round. These ceramic trimming tools aren't expensive, like $1.79 from AliExpress. So this is the problem, people try and use screwdrivers. That pin doesn't need soldering, but presumably is for stability. Good. Right. So now, of course, that's going to have to be retuned. There we go. Well, here's the moment of truth. See what the cyanide is now. Well, that looks like 12. It's 0.21 and a bit. So I'll put 0.21. 10 is just off our 0.2 scale, so it's better than 0.2, and our 20 is now 0.46. What a flying machine, that is fantastic. Now the squelch is bound to have been totally altered. Let's see what happens. Full squelch, still 100 microvolts. Hasn't changed. You see, I'm a liar. And 0.6 exactly the same. That's brilliant. That saved me fiddling with that. So that's really good. 4 watts and as sensitive as that. See why they were £89.99. 40 years later, still capable of fantastic results. Now I've got a broken PA socket, so that's going to have to come out, and it's a bit of a swine to do. I've got to do something about that meter. So as far as the video goes, we'll call it a day at that point, and we'll come back probably in 90 minutes when I've done all that. Right, so having done all those things, the power connector, the PA socket, the meter lamp, and unjamming the meter, hopefully we can calibrate the meter. Helps if I plug an extension speaker in. Oh, I've missed those two screws out of the back. Of course, I can't spot the other one, can I, right now? Right, we'll try it again. And the PA speaker, because I've changed the PA socket. Right, here we go. So we've got an S9 equivalent signal of 100 microvolts on the signal generator. I'll show you the attenuator. Picture into pictures on, which I think it is. So that needs to come up. Yeah, we've got a slightly sticky meter. Well, it's better than no meter. And on transmit, just turn that signal off. On transmit, we want it to read 4. Which it does. Right. There we are. We are done if PA works. Testing 1 2. Testing 1 2 3. It does. We've cleaned the back of the printed circuit board, so that's quite an improvement. Boomerang Nightingale is the call sign scraped into the fascia. we've got an excellent performing set, 40 years old. I won't put any screws in yet, we do the on the air test and come back. Bring Gilden for a copy. Oh, nearly got a copy then, but he's probably on a burner. Yeah, dimmer only dims the LED on these. One Anna, Roger. And there we have it. A Fidelity 2001 from 1981 using the Cybernet 002F chassis.
So I'm not parting with either. Oh, you've got two then, haven't you? Van off, please. Right, but I'm not going to carry a rig downstairs and bring it upstairs again. I'll leave one on down there and one on up here. You're just so